Welcome to this explainer. Okay, so have you ever actually stopped to wonder how your text messages, your favorite streaming shows, or even those intense online gaming sessions physically travel across the vast expanse of the internet to hit your screen? I mean, we tap, we click, we watch, but right underneath that seamless experience, there's this massive, completely invisible logistical operation moving literally billions of bits of data every single second. So today we're going to uncover the hidden mechanics that make all of this possible. Think about a daily digital frustration we all have, or, maybe a modern miracle we completely take for granted. Why is it that when you shoot a WhatsApp message to a friend, every single letter, emoji, and exclamation point arrives perfectly intact? But then, when you're in a fast-paced online multiplayer game, the system suddenly cares way more about blistering speed than making sure every tiny piece of data arrives flawlessly. Like, how does the internet actually know when to be a perfectionist and when to be a total speed demon? Well, the answer to that mystery actually comes down to two incredibly important networking protocols. Okay, let's dive into this. Section 1. The Internet's invisible couriers. Meet the contenders. To solve our mystery, we really need to meet the two main contenders operating behind the scenes. In the world of computer networking, specifically in what's called the transport layer, we've got TCP, which stands for Transmission Control Protocol, and UDP, or User Datagram Protocol. Both of these are transport layer protocols, and honestly, at the end of the day, their shared goal is super simple. They just move data from one device to another over the internet. But as you're about to see, they achieve this goal in radically, and I mean fundamentally different ways.
Moving right along to Section 2. TCP, the perfectionist, the careful courier.
So think of TCP like sending a highly sensitive, incredibly important package through a physical courier service. You want absolute, verifiable proof that it arrives safely without anything getting lost along the way, right? Let's methodically walk through this super reliable process. First off, TCP establishes a firm connection between the sender and the receiver. It's kind of like a digital handshake, saying, hey, are you ready? Because I'm ready. Then it breaks your data down into smaller pieces. We call these packets. And this is absolutely crucial. It numbers every single one of them. Next, it sends them out one by one and actually waits for an acknowledgement from the receiver. And if a packet gets lost in transit, no big deal. TCP realizes it's missing and just resends that specific lost packet. Finally, because everything is numbered, the receiver reassembles all the packets in the exact, perfect order. It's methodical, it's careful, and it makes TCP incredibly reliable.
Section 3. UDP, the speed demon. Fast and unchecked. Now, what if you just don't have time for handshakes and return receipts? If TCP is our careful courier, well, UDP is an entirely different beast, where speed is literally the only thing that matters. Just imagine throwing flyers out the window of a moving vehicle. You just simply keep sending them. You're not stopping the car to check if someone caught the flyer. You don't check if they're reading them in the right order. You honestly don't even know if half of them just blew away in the wind. UDP does not establish a connection first. It just fires off packets blindly without checking if they arrived, if they're in sequence, or if anything was lost. And because it totally skips all those extra time-consuming checks, UDP is incredibly, blazingly fast.
Now, what's really interesting here is Section 4, Head-to-Head Protocol Showdown, when things go wrong.
Look, it's one thing when the internet is working perfectly, but how do these two protocols handle adversity when data inevitably gets lost in the chaotic web of global servers and routers? Let's put them in a head-to-head showdown and look at packet loss. With TCP, if just one single packet goes missing, the whole system hits the brakes. The receiver basically says, wait, hold on, I didn't get packet number 3, and it requests it again. Everything literally waits for that retransmission before moving on. Now look at UDP. If packet number 3 is lost, UDP just drops it, skips it entirely, and moves right along to packets 4, 5, and 6, with zero waiting, absolutely no retransmission. This wait and retransmit behavior of TCP ensures absolute perfection, but that drop and move on attitude of UDP is exactly why it has a much, much lower delay. So, let's rapidly summarize this technical showdown. This really cements the whole reliability versus speed dichotomy. For the connection itself, TCP is connection-oriented. It sets things up first, while UDP is connectionless, just firing away. When it comes to reliability, TCP guarantees delivery. UDP absolutely does not. And because of that, when we look at speed, TCP is inherently slower due to the overhead of all those acknowledgements, while UDP is way faster since it skips the extra checks. TCP also ensures your packets arrive in the correct order, whereas UDP, no guarantee whatsoever. And finally, TCP performs extensive error recovery, while UDP basically settles for basic error detection. And this brilliantly illustrates Section 5, Real-World Battlegrounds, where speed meets accuracy.
You see, these aren't just abstract textbook concepts. They actually dictate how our digital tools function every single day. TCP is deployed whenever accuracy is vastly more important than, say, a fraction of a second of speed. We're talking about things like your daily web browsing, sending an email, online banking, cloud storage, and file transfers. Think about downloading a PDF document for work or school. If you used a protocol that just dropped data to save time, missing even one single page or even just a few lines of code would corrupt the file and make the entire PDF completely unusable. And that is exactly why TCP is the undisputed champion here.
On the flip side, let's take a look at the UDP applications. UDP takes over whenever speed matters more than perfect delivery. This is the engine behind your online multiplayer games, live video streaming, voice calls, and video conferencing. Imagine you're on a live video call. If a split second of data gets lost, losing one single visual frame really isn't a big deal. Your brain barely even registers the tiny glitch. But if that same video call used TCP, everything would completely freeze while the system halted to request that missing frame, causing massive, incredibly frustrating lag. In these real-time scenarios, UDP is just clearly the preferred choice.
Let's move to and see how this builds into Section 6, the ultimate memory trick, locking in the lesson.
If you're studying computer networking, maybe prepping for a certification course like the CCNA, or you honestly just want to lock this in your brain permanently, picture this final memory trick. Think of TCP as registered mail. When you send a letter this way, you, the sender, explicitly get a confirmation receipt proving the package arrived perfectly and safely. Sure, it takes a bit longer, but you have total peace of mind. Now think of UDP as radio broadcasting. A radio station just blasts its signal out into the world continuously. The DJ doesn't stop to check who tuned in, or if your car went through a tunnel and you lost the signal for a second. They just keep broadcasting. Bottom line, TCP equals reliable but slower. UDP equals fast but less reliable.